explainer. Okay, today we're doing something, well, a little bit unusual, but I promise you it's absolutely fascinating. We're actually diving into a document most folks would just completely ignore. A totally dry physics answer key. You know the kind, just pages and pages of numbers, short phrases, and formulas. But actually, scratch that. When you really look closely, it isn't just a boring textbook appendix. It's literally a thrilling, sparkly story of how the universe truly works. So we are going to reverse engineer these answers and decode the hidden laws of electromagnetism together. Think about a QR code for a second. An adorable little square of pixels that just looks like absolute gibberish, right? Until you scan it with your phone and boom, it's a map or a website. Well, the list of numbers we're looking at today works exactly the same way. It contains this hidden, beautiful reality just waiting to be unlocked if we're willing to look a little closer and translate the math back into the real physical world. So, let's dive right in. Take a look at this absolutely mind-bending number, straight out of Chapter 1. 2.4 times 10 to the 39th power. Our source tells us this is the ratio of electric force to gravitational force between an electron and a proton at the exact same distance. Think about what that actually means for a second. Gravity is the force that holds giant planets in orbit and creates literal black holes. Yet on a microscopic scale, the electric force is so much stronger than gravity that you have to multiply it by a 10 with 39 zeros behind it just to compare them. It's an absolutely jaw-dropping difference in power. No contest. Which brings us to Section 1, the power of the spark, all about static electricity. Our answer key spells out the fundamental, unbreakable rule of the static world perfectly. Charge is not created or destroyed. These tiny, immensely powerful charges are essentially immortal. They're merely transferred. So when you rub a balloon on your hair, you aren't creating electricity out of thin air. You're just playfully hopping these immortal charges from one object to another. The total amount in the system, it always remains perfectly balanced. So, we know what happens when a charge sits perfectly still. We get these massive electric forces and absolute conservation. But a universe standing perfectly still would be pretty boring, right? What happens when you take these incredibly powerful charges, give them a push, and set them in motion? And that leads us to Section 2, the flow of energy, where we look at electric current. Now, what's really interesting here is how perfectly the energy divides itself. Our source outlines a circuit with different branches, labeled AB, BC, and CD, and shows exactly how the current splits up into these neat little fractions, like 4/17 and 6/17 of an amp. It routes the flow gracefully through this complex little circuit maze, always knowing exactly where to go, adding up perfectly to a total current of 10/17. Honestly, it's like a beautifully choreographed dance of electrons. But hey, it's not all gentle, graceful streams. The answers in Chapter 3 reveal a hidden danger. There's a vital note stating that a series resistor is required to limit the current drawn from an external source. Why? Well, because without it, the current will be dangerously high. Without these essential electrical speed bumps, our cute little circuit would unleash a massive, completely uncontrolled surge of energy. Okay, so if static charges give us intense electric force, and moving charges give us a flowing, sometimes dangerous current, what invisible force do moving charges create next? Because it's not just more electricity, it actually transforms into something else entirely. Let's look at Section 3, the magnetic twist, exploring invisible fields. The really crucial point here is that magnets have preferences. They want to be cozy. Our source details this explicitly in a problem about magnetic moments. When a magnet's moment aligns parallel with a magnetic field, the energy state is negative, meaning it finds stability. It's happy. But when it's forced anti-parallel to the field, the energy state becomes positive and highly unstable. Nature, as it turns out, really prefers the path of least resistance and maximum coziness. But nature's rules can also be wonderfully flexible. The text gives us the formula for magnetic torque. Tau equals N times I times A cross B. But the most beautiful part of this answer is the little note attached to it. It says this formula is true for a planar loop of any shape. Whether your wire loop is a perfect, rigid little circle, a rectangle, or a squiggly star, as long as it's flat, that magnetic torque formula remains beautifully true. Okay, so we've seen electricity make magnetism. Flowing currents create these magnetic fields that twist all around them. But nature loves symmetry, right? So can we reverse engineer this? Can a magnet somehow conjure up electricity out of nothing? Section 4, the grand unification, stepping into electromagnetic induction. The answer key for Chapter 6 reveals that nature is, well, wonderfully stubborn. When a magnetic flux through a surface increases, say a magnetic field is getting stronger or a loop is changing shape, an induced current immediately springs into action. But it doesn't just go along for the ride. No, it pushes back. The source notes that the induced current produces an opposing flux. It literally fights the change to maintain its original status quo. So we have electric fields pushing and magnetic fields pushing back. What happens when this beautiful, stubborn push and pull between electricity and magnetism breaks free from the wires and the magnets and just ripples out into empty space at top speed? Welcome to Section 5, The Birth of Light, all about electromagnetic waves. Here we see the ultimate unification. First, our answers tell us that the electric, or E, and magnetic, or B fields are mutually perpendicular. They fly through space locked in a perfect right-angle embrace. Second, they travel in a vacuum at the absolute speed limit of the universe, exactly 3 × 10⁸ meters per second. And finally, their energy density is shared perfectly equally. The energy in the electric field perfectly matches the energy in the magnetic field. It is, quite literally, cosmic harmony. And what's really amazing is the incredible range of this light. Our source compares 2 wildly different phenomena based purely on their photon energy. Depending on how much energy these tiny little photons carry, they do vastly different things. At a gentle 2.5 electron volts, we get visible light, the radiation that lights up our rooms and paints rainbows. But crank that up to 1.24 million electron volts, and you aren't seeing colors anymore. You are witnessing massive, powerful gamma rays born from the transitions inside a nuclear core. It's the exact same fundamental mechanism, just scaled up to unimaginable power. Which leaves us with one final thought to ponder today. We just traced the breathtaking journey from immortal static charges to flowing currents to twisting magnetic fields, all the way up to the birth of light itself. And we did it just by reading the back pages of a physics appendix. If all the magnificent secrets of light, matter, and energy were hiding right there in this plain list of test answers, what other invisible wonders are waiting for you to decode in the world around you? Keep your eyes open, keep analyzing, and I'll catch you on the next explainer.